Good day, viewers. My name is Agali Belinda Chizob. I'm taking on the subject chemistry and the topic water, solutions, and solubility. By the end of the lesson, students should be able to draw the structure of water, list the physical and chemical properties of water, describe a test for water, list the sources of water, outline the steps required in the treatment of water for town water supply, and itemize substances needed for treatment of water and the use of each. Water is an odorless, colorless, with an insipid taste liquid that can dissolve so many substances. A water molecule is formed by the covalent combination of two atoms of hydrogen and one atom of oxygen. Remember that covalent combination simply means sharing of electrons, whereby each atom contributes equal number of electrons for them to share. It leads to the formation of a single covalent bond within the molecule. There are two lone pairs of electrons on the central oxygen atom that are not used in bonding. They repel each other, causing the molecule to acquire a V shape. This is the structure of a water molecule. Here we have hydrogen. Here we have hydrogen atom, and this is the oxygen atom. You can see the two pairs of electrons that are lone, that are not participating in the bonding, while this is the hydrogen electron and this is the oxygen electron. You can see the V shape of the water molecule. Due to the electronegativity difference between atoms of hydrogen and oxygen, the two covalent bonds in the water molecule are polar, and the entire molecule is also polar. Again, there are hydrogen bonds between water molecules. Attractive forces due to hydrogen bonds are fairly strong and are responsible for the existence of water as a liquid at room temperature. You can see here, oxygen is connected to hydrogen. Oxygen connected to hydrogen, oxygen connected to hydrogen, forming the hydrogen bonding in water. This hydrogen bonding can lead to high viscosity, high surface tension, and the high boiling point of water. Unique properties of water. Water has a maximum density of 1.0 gram per cm cube at 4 degrees centigrade. Below 4 degrees C, water will expand and form an ice. Remember that below 4 degrees C is a cold temperature. Instead of water to contract, it will now expand and form ice, a solid. Ice water contains more hydrogen bonds than liquid water. This leads to an expanded structure and a low density of ice. 3. As ice is being warmed, the heat absorbed is used to break the extra hydrogen bonds in the ice, so that the molecules come together to fill the empty spaces. This leads to contraction between 0 to 4 degrees C. Above 4 degrees centigrade, normal expansion will follow. At atmospheric pressure, water boils at 100 degrees C and changes to steam. The relative high boiling point of water is due to the hydrogen bonds between water molecules. Physical properties of water. Pure water is a clear, colorless, and odorless liquid. It has a characteristic insipid taste. It has no effect on litmus paper. It boils at 100 degrees C under atmospheric pressure. It also freezes at 0 degrees Celsius. Chemical properties of water. Reaction with metals. Metals can be divided into 3 categories based on their reacting with water: active, semi-active, and non-reactive metals. Active metals. Metals such as potassium, calcium, and sodium react vigorously with cold water, giving off colorless and odorless hydrogen gas and forming an alkaline solution. This reaction is exothermic. In fact, you will hear a sound that sounds like a pop due to the formation of hydrogen gas. Semi-active metals. Metals such as magnesium, aluminum, zinc, and iron are not reactive towards cold or hot water. However, they readily react with steam at red heat to liberate hydrogen gas and produce the corresponding oxide of the metal. Here you can see magnesium reacting with steam to form magnesium oxide and hydrogen gas. This is iron reacting with steam to form iron 3 oxide and then water. This is the rust that we see on metallic surfaces like iron or burglary proof. Inactive or passive metals. Metals such as lead, copper, mercury, silver, and gold do not react with water or steam. Reaction with non-metals. When steam is passed over white-hot carbon, a mixture of carbon dioxide and hydrogen gas is produced. This is what we refer to as a producer gas, and is very important in the industry for heating. Chlorine also dissolves in water to form hydrochloric acid and monooxochlorate 1 acid. Reactions with oxides of metals. Oxides of metals are called basic oxides. Basic oxides that are soluble in water to give the corresponding hydroxides are called alkalis. Examples are sodium oxide, potassium oxide, and calcium oxide. You can see sodium oxide reacting with water to form sodium hydroxide. Reactions with oxides of nonmetals. Oxides of nonmetals are either acidic or neutral. Those that are acidic dissolve in water and react with water to give the corresponding acids. Acidic oxides are called acid anhydrides. An acid anhydride is an acidic oxide that dissolves in water to produce an acid. Example, sulfur 4 oxide, sulfur 3 oxide, nitrogen 1 oxide, carbon dioxide, phosphate, and then phosphide. You can see sulfur 4 oxide reacting with water to form trioxosulfate 6 acid, and sulfur 3 oxide, reacting with water to form tetraoxosulfate 6 acid. Action of water on metallic carbides. When cold water is added to metallic carbide, there is effervescence. A gaseous hydrocarbon and a corresponding hydroxide are produced. The gaseous hydrocarbon is ethane. Test for water. Water will turn white anhydrous copper sulfate powder blue, or blue anhydrous cobalt 2 chloride powder pink. This is not an effective test for water, because anything that contains water will turn white anhydrous copper sulfate powder blue, or blue anhydrous cobalt 2 chloride powder pink. But any liquid that boils at exactly 100 degrees Celsius at atmospheric pressure, freezes at 0 degrees C, and has a density of 1 gram per cm cube is pure water. These are the criteria for purity of water. Sources of water. Almost everything on earth contains water. Even you as a human being contain water. Natural sources of water are rain, spring, well, rivers, lakes, ocean, and seas. Water can also be sourced from boreholes and dams. Treatment of water for town water supply. The treatment or purification of water for town supply usually passes through the following stages: aeration or sedimentation. When water is stored in the reservoir for many days, to allow more to settle down by sedimentation and to kill the bacteria by exposure to sunlight. Number 2, coagulation. After aeration and sedimentation, water is made to pass through large settling tanks in the waterworks, where calculated amounts of potash alum or sodium aluminate 3 is added for the coagulation of clay or colloidal particles. Number 3, filtration. The sediments and the coagulated particles are removed by passing the water through sand beds composed of layers of coarse gravels, then through layers of fine sands, and finally through layers of fine charcoal to remove fine sediments and unwanted coloring matter. Some of us might be confused, why are we putting charcoal again? Charcoal will help to remove the unwanted coloring matter in the water. Chlorination, iodination, and fluorination. Water is treated with calculated amounts of chlorine to kill bacteria or germs. Calculated amounts of iodine salt in the form of iodide is now being added to treated water for town supply for the prevention of goiter caused by iodine deficiency in human body. Sometimes, calculated amounts of soluble salt of fluorine is added for the prevention of tooth decay. pH measurement. The water is subjected to quality control by pH adjustment by the addition of calculated amounts of lime in order to maintain a pH between 6.0 and 8.0. Distribution. The treated water is finally pumped to sealed reservoirs in the tank ready for use. Evaluation. Number 1, explain why water is referred to as a universal solvent. This is because water can dissolve so many things on earth because of the presence of hydrogen bonding. Mention 2 elements that will react with cold water, producing hydrogen and an alkaline solution. Remember that we classified our metals into 3: active metals, semi-active metals, and then inactive metals. It is the active metals like sodium, calcium, potassium that will react with cold water to produce hydrogen and an alkaline solution. What is responsible for the relatively high boiling point of water? This is because of the presence of hydrogen bonding in water. Number 4, list 3 natural sources of water. You mentioned many sources like rainfall, seas, ocean, rivers, wells, dams, and so on and so forth. Outline the steps for the treatment of water for town supply. When you are outlining the steps for the treatment of water for town supply, please take care to mention it sequentially, meaning that aeration and sedimentation will come first, followed by coagulation, followed by filtration, followed by chlorination, fluorination, and iodination, followed by after chlorination, iodination, and fluorination, you adjust the pH before you finally distribute. Number 6, what is the function of the following in town water supply? Alum is used for coagulation, while chlorine is used to kill bacteria. Sunlight helps in aeration, while lime helps in pH adjustment. We have come to the end of the lesson, and I hope we have learned how to treat water for town water supply. Thank you for listening.